Light is absolutely everywhere. It's how we see our entire world. But have you ever stopped to think about how it actually works? Well, you might be surprised that pretty much everything light does, from your reflection in a mirror to how your glasses help you see, boils down to just two simple moves. We're going to break them down: the bounce and the bend.
Okay, so picture this. You look at yourself in a flat window, and yep, there you are, looking totally normal. But then you grab a shiny spoon from the drawer, and suddenly your face is all tiny and upside down on one side, and stretched out and weird on the other. What is the deal with that?
Well, the answer to that spoon mystery and a whole lot of other optical tricks isn't some crazy complicated physics equation. Nope, it's all about whether light is bouncing off something or bending through it. That's it, bounce and bend. So first up, let's tackle the bounce.
When we talk about light bouncing, we're really just talking about reflection. This is what's happening every time you see your image in any shiny surface, whether it's a calm lake or the mirror you use every morning.
So what is reflection, really? It's just light hitting a super smooth, polished surface and getting sent right back. The light from you hits the mirror and bounces straight into your eyes, and that creates the image you see. But here's the cool part. It's not a random bounce. It's perfectly predictable, and it follows two beautifully simple laws.
And here are those laws. Seriously simple, right? First, the angle that light hits a surface is the exact same angle that it bounces off. Think of it like a perfect bank shot in a game of pool. Second, the incoming light, the outgoing light, and an imaginary line drawn straight out from the surface, what scientists call the normal, they all exist on the same flat two-dimensional plane. The main thing to remember is that these two rules apply to every single reflection, whether the surface is flat as glass or curved, like, well, a spoon.
Which brings us right back to our spoon. A spoon is basically just two curved mirrors stuck together. The inside part, where the food goes, that's a concave mirror. It caves in. And the back of the spoon, that's a convex mirror. It flexes out. This one simple difference in the curve completely changes how they bounce light back at you.
Now, I know this table looks a little technical, but the idea behind it is actually pretty straightforward. With a concave mirror, the inside of the spoon, what you see totally depends on how close you are. Look at that image nature column. See how from far away the image is always inverted? That's your upside down face in the spoon. But then, look at that last row. When you get really, really close, it suddenly flips upright, erect, and gets bigger. It's like magic.
And this ability to both focus light into a beam and to magnify things up close makes concave mirrors super useful. They're inside your car's headlights, turning a tiny bulb into a powerful beam of light. They're used as shaving mirrors or makeup mirrors because they give you that bigger close-up view. Dentists use them for the exact same reason. And you can even build giant ones to act as solar furnaces, focusing sunlight to one single intensely hot point.
Okay, now let's flip the spoon over to the back, the convex mirror. Its behavior is way simpler. Just look at the image nature column. The image is always upright and it's always smaller. It never flips, no matter how close or far you get. This consistency is its superpower.
And this awesome predictability is exactly why convex mirrors are so important. The fact that they always show you an upright image, and, because they curve outwards, give you a much wider field of view makes them absolutely perfect for things like the passenger side mirror on your car. They let drivers see a huge area behind them, safely. So that's the bounce. Now, are you ready for light's other signature move, the bend?
All right, we've pretty much mastered the bounce. Now it's time for light's second big trick, the bend. This is what scientists call refraction, and it happens whenever light passes from one clear substance into another.
I'm pretty sure you've seen this a million times, right? You put a straw or a pencil in a glass of water and you look at it from the side. Right where it hits the water, it looks bent, like it's broken. But you pull it out and, of course, it's perfectly straight. That weird illusion is refraction in action.
So here's the key idea. Refraction is just the bending of light when it crosses from one material to another, like from the air into water. But why does it bend? Because the speed of light isn't always the same. It actually changes speed depending on what it's traveling through.
We have a way to measure this slowing down effect, and it's called optical density. Now, this has nothing to do with how heavy something is. It's just a measure of how much a material puts the brakes on light. So water is optically denser than air. When light rays go from the air into the water, they slow down and bend. Then when they leave the water and go back to the air, they speed up and bend again. And that two-part bend is what creates that broken pencil illusion.
Okay, so if we know exactly how light is going to bend when it passes through a material, that means we can actually shape that material to control the light. And that is exactly what a lens is. It's just a carefully shaped piece of glass or plastic designed to bend light in a very specific, useful way.
And hey, what do you know? Just like with mirrors, we have two main types of lenses. A convex lens is the one that's thicker in the middle. It takes light rays and brings them all together or converges them at a single point. You know, like a magnifying glass. A concave lens is the opposite. It's thinner in the middle, and it spreads light rays out or diverges them.
And check this out. There's a really cool parallel between lenses and mirrors. A convex lens behaves a lot like a concave mirror. It's the versatile one that can make all different kinds of images depending on distance. And the concave lens, just like a convex mirror, it's the consistent one. It always makes a smaller, upright image.
So how do we measure all this bending power? Well, if you've ever had an eyeglass prescription, you've seen the unit. It's measured in diopters. All you need to know is the higher the diopter number, the stronger the lens is, and the more sharply it bends light.
So we have the bounce, which is reflection, and we have the bend, which is refraction. On their own, they're both pretty interesting, but the real magic, the stuff that lets us see everything, happens when they start working together.
Just about every cool optical tool you can think of relies on a precise combination of both mirrors and lenses. Your camera uses lenses to bend in focus light. A giant telescope uses a huge concave mirror, that's the bounce, to gather faint starlight, and then a series of lenses, that's the bend, to magnify the image. Even your own eye is a bounce and bend machine, with a lens that bends light to focus it on your retina.
So, from seeing your goofy reflection in a spoon to capturing images of galaxies billions of light years away, it's all governed by the same two simple rules. Our entire understanding of how to see the universe is built on mastering the bounce and the bend. It just makes you wonder, what will that mastery let us see next?